Alright, let's look at halogenation. Now what we're looking at here is the halogenation of an alkene in a ring, because that's going to have stereochemical consequences associated with it. And what's going to happen is that the bromine is going to add to the double bond on the ring and form this brominium ion. Now the way this is oriented is that the brominium ion is actually sticking upwards relative to the plane of the ring. So the Br minus will come in and attack from underneath and then push this up. The stereochemical consequences for this is that the Br minus that attacks from underneath will be sticking down, while the Br that was attached here is sticking upwards. Doesn't this look a lot like an epoxide ring opening as well? Now you can see the Br sticking down and Br sticking up, and that's why these are this way over here. Now you'll notice I've drawn two products, and the reason for that is because the Br minus could have come in and attacked from this side or this side, and that would have given this product had the Br minus attacked from this side. Now take a look and you can see why. If we flip this around, this is actually the mirror image of this compound, and it turns out these mirror images are not superimposable. Since they're not superimposable, these two products would be enantiomers. So this is actually a reaction that gives two different products that are each enantiomers. Right, let me go through the mechanism once again so you can see the flow of the arrows. So what's going to happen is that we're getting two electrons from the double bond, we're going to get two electrons from the double bond, and the electrons are going to go into the space between the Br and the C. I could draw it to the Br too if I wanted to, but I'm just going to draw it into the space between the C and the Br because I want to say that I'm forming a bond there. Now what I'm going to do is I'm going to take two electrons off the Br, and it's going to form a bond between this C and the Br as well. Simultaneously, the Br will leave as Br negative. Now because the Br is actually losing an electron to form a new bond with this C, the Br will actually end up being positive. For the reasons I explained earlier, the Br is actually drawn as a wedge because it is actually above the plane of the ring. See, right over here. Yes, the Br plus is sticking upwards, so any attack is going to occur from the Br minus coming underneath. So we have a new bond from the Br. This bond broke, but this bond remained intact and it's still sticking up. So this bond is gone, but this one remains intact and is still sticking upwards with this Br sticking down.